The weirdest secrets of quantum physics are not mysteries of nature. They are the exact lines of software code that build our simulated reality.
For over 100 years, the smartest minds on Earth have been completely baffled by how tiny particles behave when we are not looking at them. They teleport instantly, exist in multiple places at once, and completely break all the traditional rules of a solid physical world. This is not because nature is inherently magical or impossible to understand. It is because our universe is not made of physical rocks and heavy metal at all. It is built entirely out of digital data strings and mathematical equations.
This matters immensely to your life because it proves that nothing around you is truly permanent or solid.
The room you are sitting in, the screen you are staring at, and the body you inhabit are all being rendered in real time by a grand cosmic computer processor. Today, we are going to break down the incredible science that links quantum mechanics directly to modern computer programming. We will give you massive value by showing you the literal programming rules hidden inside our physics textbooks. You will finally understand how the universe saves its processing power when you walk through an empty house. If you're ready to uncover the truth behind our simulated universe, hit like and subscribe to join us on a journey through the mysteries of simulation theory. Let's get started. To fully comprehend the structure of our world, we must connect simulation theory directly to the deep rules of quantum mechanics. In the early 1900s, famous physicists began to look closely at the smallest building blocks of matter, like atoms and electrons. They expected to find tiny solid marbles spinning around in perfect, predictable paths. Instead, they discovered a chaotic world of numbers, probabilities, and sudden shifts that made no sense under old scientific models. This historical context is vital because it marks the exact moment humanity first touched the underlying software of the matrix. You realize that at the deepest layer of existence, solid matter completely disappears and is replaced by mathematical information. This topic is highly relevant right now because our own computer technology has finally advanced to a level where we can recognize these patterns. When our game designers build a massive virtual world, they use optimization scripts to make sure the computer only loads the graphics that a player can actively see. In the fascinating sections ahead, we will explore how our universe uses this exact same strategy to save its central processing memory. We will look at how particles communicate faster than the speed of light, acting like instant data transfers on a single hard drive. We will also examine how the universe sets a maximum speed limit on light to prevent the master processor from overheating. Get ready to view your physical life as a beautifully designed digital program. Why does reality seem to adjust itself based on our human actions? The answer will fill you with curiosity as we prepare to face the profound problem that quantum physics poses to our standard view of existence. The ultimate challenge we face when examining quantum mechanics is realizing that our physical world behaves exactly like a video game map. This sub-niche of simulation theory is profoundly fascinating because it completely destroys the idea that our universe exists independently of us. The biggest problem in physics today is something called the measurement problem. In simple terms, when scientists shoot a tiny electron through a barrier, it behaves like a wavy ripple of probability, spreading out and passing through multiple holes at the exact same time. It does not choose a single path. It stays as a mathematical equation floating in a cloud of endless possibilities. The very second a human researcher places a camera or a sensor to observe the electron, the wave instantly collapses. The particle suddenly acts like a solid, real object and chooses one specific point to land on. This thought experiment poses an intriguing riddle to our common sense. Why does a dead piece of matter change its behavior just because a conscious mind is watching it? The system keeps this mystery deep, but the answer is obvious when you look at it through a computer lens. The electron does not choose a location until the user looks at it because the simulation engine refuses to waste its processing units, rendering a solid object in an empty, unobserved room. This presents a massive challenge to old-fashioned science, which insists that the world is real whether we look at it or not. Deeper revelations tease a world where the physical structures around you are just empty data code, waiting for your human eyes to turn them into real shapes and colors. Let us enter a vivid mental scene. to fully experience the psychological weight of this coded reality. Imagine you are walking through a dense, quiet forest late at night. You can hear the leaves rustling above your head, and you can feel the cold dirt beneath your shoes. In your mind, you believe that the entire forest exists exactly as it is, spanning for miles in every single direction around you. But from a quantum perspective, this is a complete illusion. Simulation engine is only rendering the specific trees, paths, and rocks that fall inside your immediate field of vision. The moment you turn your back on a faraway mountain, that mountain instantly stops being a solid object. It is instantly reduced back to a simple string of mathematical probabilities and dormant data code on the master server. The camera of your awareness moves forward, and you realize that your own observation is the exact tool that builds the world frame by frame. This brings up deep philosophical and existential questions that can shake your identity. If your observation creates the world, what happens to your house when you go to sleep? Does the entire neighborhood dissolve back into the cosmic mainframe until the morning light hits your window? This thought creates a powerful psychological cliffhanger in your mind. We are living inside a responsive digital landscape that constantly matches our movements, updates its graphics, and builds the environment based on where we look. Boundaries of your life are not set by physical distances, but are managed by software limits designed to keep you playing the game without ever noticing the machine running behind the screen. The single most powerful proof that quantum mechanics is the source code of reality is the phenomenon known as quantum entanglement. Einstein famously called this spooky action at a distance because it seemed to break all the regular rules of space and time. When you take two twin particles and entangle them, they become permanently linked together. If you keep one particle on Earth, blast the other particle across the universe to a distant planet billions of miles away, they still react as one object. If you spin the local particle to the right, the distant particle instantly spins to the left at the exact same millisecond. Scientific logic is completely impossible in a real physical world because information cannot travel faster than the absolute speed limit of light. But in a simulated universe, this mind-bending connection is incredibly easy to explain. Two particles are not actually separated by billions of miles of physical space. They are just two neighboring pixels on the exact same flat computer monitor driven by the same line of code. Space is completely artificial. Maximum speed of light is not a random feature of nature. It is the clock rate of the master processor, setting the maximum speed at which data can update across our local map.
This realization fills us with an absolute sense of maximum inspiration and awe. We are looking directly at the mainframe code, a grand digital creation.
The system maintains a level of mystery by keeping these quantum behaviors hidden from our giant human eyes, but it foreshadows a future where we might learn to hack these data links to teleport across the matrix instantly. To bring our incredible journey to a close, the shocking rules of quantum mechanics offer clear proof that our universe runs on software code. We have explored how tiny particles refuse to lock into a single physical location until a conscious observer looks at them, matching the exact resource-saving code used in modern video games. We analyzed the incredible mystery of quantum entanglement, showing how instant communication across the cosmos proves that physical space is an illusion built on a single flat computer chip. We also looked at how the speed of light serves as the ultimate processing speed limit for the master engine, preventing the system from crashing under a heavy load. This knowledge infuses our everyday lives with a profound sense of mystery and immense wonder. It shows that you are not a helpless observer trapped in a cold, uncaring world of solid rock. Instead, you are an active participant whose very awareness helps to render the beautiful digital map around you. We should use this inspiration to live each day with deep focus and extreme curiosity, knowing that the world is highly flexible and responsive to our presence. Not let the heavy routines of life fool you into thinking this matrix is fixed and permanent. Look closer at the patterns, remember the math that runs the skies, and continue to question the true nature of your reality, because the code of the universe is waiting for us to fully read its design. What are your thoughts on the connection between quantum physics and computer code? Do you believe the way particles behave when observed is absolute proof that we are trapped in a giant simulation? Want to read your fascinating theories, so leave a comment down below. If you want to see more mind-bending evidence about the Matrix, make sure to watch our next video. If you enjoyed this exploration of simulation theory, don't forget to like this video, subscribe to our channel, and hit the notification bell so you never miss an upload. If you're ready for more interesting content on the simulation theory, make sure to check out our other videos. Thank you for watching.